7.7a homework. So in this case, we're going to multiply the 5 and the 9. 5 times 9 is 45, and then we're going to keep the y, and that's it for the first one. Second one, we have a negative times a negative, which gives you a positive, and you have 8 times 5, and you have r times r, right? So 8 times 5 is 40. And r to the first times r to the first, 1 plus 1 is 2. Or r times r is r squared. So in this case right here, we say 5 to the fourth times 5 to the third. And that would give us 5 to the fourth plus 3. Right, we add the exponents together. When we multiply two of these factors with the same base, then we add the exponents together, and that gives us 4 plus 3, which is 7, so 5 to the 7th power. Now we could figure out what this is actually equal to, but we'd probably have to plug it into a calculator. Right? Okay. So we move on to this case right here, so we say 3 to the 2nd power times 3 to the negative 7th power, and this would be 3 to the 2nd plus the negative 7, which would give us 3 to the 2 plus negative 7 is a negative 5. Now, to get rid of that negative exponent, we'd have to write it on the bottom. We have to switch position from numerator to denominator, and that switches the exponent sign. So we'd end up with 1 over 3 to the 5th power. And we could simplify that if we wanted to. So that would be 1 over 243. So if we wanted to simplify the following using the laws of exponents, again, we have the same base, they're multiplied together, so we add together the exponents. So b to the 14th plus b to the 2nd is b to the 14th plus 2, which is b to the 16th. Over here, we just keep the 9. We have 9a to the 4th times a to the 2nd. We keep the 9. And a to the 4th times a to the 2nd, we add the exponents together, 4 plus 2, which gives me 9a to the 6th. Over here we have a positive 8 times a negative 5, which gives me a negative 40. And then we have x to the 2nd. So then we have x to the 2nd times x to the 1st. There's an implied or understood 1 there. Then we have multiplied by y to the 1st, implied or understood 1 if you don't see it, times y to the 8th. Right? So just like 8 times negative 5 was negative 40, we have 8 to the 2nd times 8 to the 1st, so 2 plus 1 is 3. Then we have y to the 1st times y to the 8th, and that means 1 plus 8 is equal to 9. Move on to the next one. So we have a negative 2 times a 7 times a negative 5. A negative times a positive times a negative is a positive. 2 times 7 is 14. 14 times 5 is 70. So negative 2 times positive 7 is negative 14. Negative 14 times negative 5 is a positive 70. All right, so the next part is we have a to the implied or understood 1st power times a to the 4th power times a to the 6th power. So I'm just writing them all next to each other so you can see the product rule at play. So these are all being multiplied together. So what we have here is 1 plus 4 plus 6. So 1 plus 4 is 5. 5 plus 6 is 11. So it's a to the 11th power. Then we have a b here. Nope, no b. Sorry. And that's it. All right, so let's move on. So we're going to simplify these by multiplying. So it looks like, now if you don't see the exponent, you understand that it's a 1. So we end up with m to the 1st times m to the 8th times m to the 1st, which means we add all those exponents together. And that's where we get m to the 1 plus 8 is 9. 9 plus 1 is 10. Then we have n to the 1st times n to the 2nd. And again, since we're multiplying these and they have the same base, we simply add the exponent together. And 1 plus 2 is 3. Move on to the next one. Use the product rule to simplify the expression. Okay, now in this case, this is a little bit different in that since these do not have the same base, one is 4 to the third power and the next one is 5 to the sixth power, we just use Pemdas or order of operation. So we say 4 to the third power is 4 times 4 is 16 times 4 is 64. And 5 to the sixth power is 15,625. And then 64 times 15,625 is 1 million. So we're going to be multiplying together 4x to the sixth power times 6x to the sixth power. Since 4x to the sixth power and 6x to the sixth power, even though they're in parentheses, they actually don't completely match. What we're going to do is we're simply going to say 4 times 6 times x to the sixth times x to the sixth. So 4 times 6 is 24, and x to the sixth times x to the sixth, because they're being multiplied together and they have the same base, you're going to add the exponents together, because 6 plus 6 is 12. Next one, we have 5 times -3, which gives me a -15. Then we say a to the seventh times a to the third. So we have the same bases multiplied together, so we add their exponents together. And 7 plus 3 is 10. Next we say use the product rule to simplify the expression. Write your answer in exponential notation. Alright, so because all these have the same bases, we simply add all the exponents together because they're being multiplied together. So b to the fifth times b to the ninth times b to the eighth, you're going to say 5 plus 9 is 14. 14 plus 8 is 22. Next, we have a -8 times a +5, which will give me a -40. Then we have x to the second times x to the eighth. And since they have the same bases, we're going to add the 8 and 2 together and get a 10. So we end up with x to the 10th power. So -40 x to the 10th power is the answer. Move on to the next one. And we have use the product rule to simplify the expression. All right, so we have a -9 times a -6. Negative times a negative is a positive, and 9 times 6 is 54. Next, we have an x to the 9th times x to the 7th, and 9 plus 6 is x to the 16th. So now we have some power rules that we're going to work on. So we have 3b within parentheses to the second power. So we're simply going to bring both the 3 and the b to the second power. So we end up 3 to the second power times b to the second power. 3 squared is 9, so we end up with 9b squared. Next we have 6xy to the second power. We do the same thing, except now we're going to bring both the 6, the x, and even the y to the second power. So we have 6 to the second power, x to the second power, and y to the second power. So 6 squared is 36, and we keep the x squared and the y squared. This one's a little more complicated in that we have a coefficient outside of the parentheses, so we have 2 parentheses x qr in parentheses to the fourth power. Now, we have to go in order of operation, so Pemdas would say we do the exponent before we do the coefficient, which is multiplication, right? So exponents before multiplication. So, I am going to bring both the q and the r to the fourth power and just keep the 2 on the outside. We don't do anything with the 2 yet. So I end up with q to the fourth power times r to the fourth power. And then we get rid of the parentheses, multiply everything inside by 2, and then we simply end up with 2q to the fourth power r to the fourth power. Move on to the next one. We have a negative to a third power, so the answer is going to be negative. And then we're going to bring everything within the parenthesis to the third power, all 3 factors, the 2, the x, the fourth, and the y to the second. Now, if you don't see the exponents understood or implied to be a 1, so in this case 1 times 3 is 3. I'll actually write it out, but you don't have to write the 1 if you don't want to. Then you put, the next one is x to the fourth power, but it's fourth power to a third power, so you multiply those together, you get 4 times 3. And then finally, the last one is y to the second power to the third power, so you're going to be multiplying 2 and 3 together. What that gives you is a -2 to the third power x to the 12th power because 4 times 3 is 12, and y to the 6th power because 2 times 3 is 6. Next, because negative 2 to the 3rd power is equal to a negative 8, we bring that down, and then we just bring x to the 12th power and y to the 6th power down. Okay. Next problem is a fraction, 4/9 to the 3rd power. So effectively, we're going to bring the numerator and the denominator to the 4th power. So we end up with 4 to the 3rd power and 9 to the 3rd power. 4 to the 3rd power is 64 because 4 times 4 is 16 times 4 is 64. And 9 to the 3rd power is 729. And 64 over 729 does not reduce, so we're done with that one. Next, we're going to move on to 1/9 to the 2nd power. The whole fraction is in parentheses, so we end up with 1 to the 2nd power over 9 to the 2nd power. Now, 1 squared is 1, and 9 squared is 81, and that does not simplify, so we're done with that one. The next one is a over b to the 3rd power. Since the fraction is in parentheses, we're going to bring both the a to the 3rd power and the b to the 3rd power. So we end up with a to the 3rd power over b to the 3rd power.